Alright, this time I will talk about the problem Agri-Net. So in this problem, what we need to do is find the minimum spanning tree of this graph. And to do that, we will use Prim's algorithm. Here's my code. The Prim's algorithm is very similar to the Dijkstra's graph algorithm, except the difference here is that we only need to find the shortest distance for every two pairs, and we will use that as our distance instead of the total distance from a node to some other node. So after reading the node, this Gij will represent that there's a path from I to j, and it has the length Gij. So here in this function, we will construct our minimum spanning tree. First, I set all the distance from 0 to n to int max. This represents that there's no path to this node I yet, so we will have to use a loop to find the final answer. And here's I set distance 0 to 0. Here you can use any variable, any number, as long as it's between 0 to n, because no matter which node you start at, you will always end up with the same minimum spanning tree because it always goes with the minimum path. So here I set it to 0 because we're at 0 already. This is the beginning of the search. And then C, this will keep track of the total cost, which is also the length, and we will return this at the end to print it out. So I created this U, meaning this represents the node that we're currently at. So I will use this function, minimum distance function, and the minimum distance function will go loop through 0 to n and find this node with the smallest distance, but also it should not be visited yet, because if it's visited, we've already looped through that node, so we don't want to go back and cause it to loop on forever. So it will return the index, and we'll check if it's -1. If it's -1, just means we've completed the minimum spanning tree and we can stop the while loop. Otherwise, we will add the distance to u into C, because we need to keep track of the total length used afterwards. And since we've used this loop, we know that this u isn't visited yet, so we have to set it to visited. And here in this loop from 0 to n, it will check our initial input. So it will check if there is a path from u to I, and if the path from u to I is smaller than the current distance to I. So this distance I, it will keep track of the distance that's closest to I, and at first, since it's all maximum, we will find a distance and set it to that. Here in all these comments, I created these as parent arrays. These can be used if you want to see how the tree is constructed. So if you uncomment all of these, you can see where the lines are constructed, and you can also see the distance and where the path came from and where is it going to. So this is what PI does. If this may be necessary in some other problems if you need to print out the path of the minimum spanning tree. So I added this as well. If this is the smallest, it's smaller than distance I, then we should know that the shortest path to go to I is by starting at node U. So we will change the parent of node I to U. But that isn't necessary in this problem, so I commented it out. And this loop, it will loop through all the possible paths that U has. And afterwards, we will find the next minimum distance, because now we've already set U to visit it, and we've updated some new distances. We can use this minimum distance again to find a new shortest distance and use that in the while loop again until we've reached the U is equal to -1. And after that, we would have already added all the distance, so we can return C and print that out at the end.